Thanks for the introduction. As we noted, my name is Scott Drapp. I'm Sales Director at Cortic AI. We're an exhibitor here this week, and I look forward to speaking with all of you. I thought I'd give a quick introduction to our members here that are part of this session and part of the panel. Their profiles are in the app, so feel free to learn more about them there, but I'll give quick intros. So we're going to get, just going to put on my glasses here. We've got Bill Thaxton and Kevin Mackey from Siemens Energy. We've got Sean Gregerson from Aviva that will follow up. We've got Jonas Helgren from Aperio Systems, as well as Tim Michelson, Rick Smith, and Alan Turner from International Paper. Just a little bit of housekeeping. If you do have a question, and we encourage you to ask questions, please post them in the app. At the end of the session, we'll open it up for Q&A and answer those questions. Additionally, I'm going to do it at the end, but I'll mention it now as well. Please rate the session and give any insight at the end of the session as to what you might want to see next year as well. We're looking for as much input there as well. So in sort of kicking things off as a group, today's session is democratizing your data. And if you think about it, that's not a new concept. It's been something we've been doing throughout industry for some time. But what we've seen is the modern needs of data have changed drastically, and that's what shifted. So you think about it sometime in the past, the needs of data, we took data related to our operations, and we looked at it in a historical perspective, or ad hoc, what happened, what went wrong. Over time, that migrated into feeding data and sharing it through your organization for, give me some insights as to what's going on real time in my organization. But with that, it's giving me ideas of what's going on real time, but it's not telling me necessarily what are the contributing factors to that data to enable me to make better decisions and share that data within the organization. So with that, we see an evolution, and at Cortic we see an evolution of the next generation of data democratization is, okay, now that we have that data and we have that real-time data, how do we take it and now start giving insights into what can I do real-time within my process, within my assets, to make changes and make a greater impact. And then we see the next evolution, and I think we'll talk about it today in some of the sessions as it relates to AI and machine learning, is what happens next when we look to do closed-loop control, autonomous manufacturing. Are we ready for that? Are we ready to share that data and input to make those decisions as a business? So we'll go through that today. The next step, too, I think, with data democratization is the needs of different users, and many more users are there than ever before. So you look across your plants, you've got everybody from operators, process engineers, reliability practitioners, management, up to executive leadership, insights to that data across the whole organization, as well as now data sharing. So that's another concept that is troublesome for a lot of folks. It's how do we start sharing data from organization to organization outside of our own enterprise? So hopefully we'll look to tackle that as a group as well. So when we look at all of the needs in modern industry, hopefully we'll tackle as a group a couple of key things. First, data quality and data types. So when you look at democratization of data, obviously we have different types of data, and that data has to be of high quality. We have to trust it. It's got to have the context that we need for the different individual and the different persona. It has to be ready. I mean, data readiness is key to all of this. So if we're going to share data for different roles, we have that data needs to be ready to be consumed to support analytics. Additionally, we'll talk and talk as a group around data governance, because when you really think about it, and for some of the individuals here, accessibility, who has accessibility to data? Data sharing, both internally and externally, how do we manage that? The whole OT and IT convergence. What does IT want? What does OT need? How do we manage that for data sharing within our organization? And then the final piece to that really is the technology. And you'll see some of that today, and some of that is how do I leverage technology to the fullest to really provide democratization of data across my enterprise and across all of the partners that I need. How do I give something to any user within our organization, leverage the cloud, leverage machine learning AI, leverage data with context to the role of that individual. So hopefully we'll tackle some of that, and with that, I'll turn it over to Bill and the Siemens team to sort of kick us off and get started.
Thank you. So we're going to do a joint presentation. My name's Kevin Mackey from Siemens Energy, and
I'm Bill Thaxton, also with Siemens Energy in the digital engineering team.
And what we're going to talk about today is, from a philosophical level, digital transformation, and what does that mean? Some of the challenges that organizations are facing when trying to decide what's the right path, because there isn't one size fits all when you talk about digital transformation. Some challenges can be unique to individual organizations, and we need to understand what those challenges are before we can set the right path. So what we're going to do to start with is to go back to the very beginning. And when you consider how much as a race we've evolved, we're now walking upright. Well, some of us are anyway. But there is a danger that we're regressing back to where we used to be with the current obsession with computing, digital, and data, and all of those types of things. So we need to be careful about where we're going. And nowadays, there seems to be so much data available, and the way that we are now managing our assets has changed dramatically. We're no longer carrying toolboxes, we're carrying tablets. So how do we cope with the vast amount of data that's now available? So you look at some of the technology and how that's evolved. And I don't know whether some of you saw earlier on, but the Boston Dynamics robo-dog was strolling around the foyer. But when you think about, where we were 30 years ago, that technology wasn't even on our radar. And here we are now. We've got robo-dogs that can do that type of thing. So the technology has advanced and evolved at a similar speed, if not a faster speed, to all of the other things that are going on within the plant at the moment. And if the last couple of years has shown us anything, with the global pandemic, the need to be able to manage data more effectively, to have the technology to do that, the number of people that have managed to successfully continue to run businesses while working at home has shown us that data and the technology that we use around that data is how all of our businesses need to be going in the future. So, we've now got to look at what we do in order to take that data and manage things more effectively, but also to look at some of the things that Scott mentioned. There's lots of data out there. Is it good data? Is it good quality data? What are we going to do with it? Are we going to collect it even if we're not going to use it? All of these things need to be answered. And I'm told that we collect as much data as possible because it's cheap to collect data and store it. Well, that's great, but at some point we've got to do something with it. And should we only be collecting data that we're going to use to actually make meaningful decisions? So those are some of the challenges that we have. And the data quality, again, based on what we see within our customer base, the data quality can be variable at best. So starting off with good quality data perhaps means that you're going to make good quality decisions when you start to use that data alongside the technology. So as we look at the digital future, I think there's a number of priorities that most organizations look at. And typically, the data aspects are the biggest priority. What have we got? How can we access it? What are we going to do with it? Maybe the second priority is the technology that we're going to use to help us analyze that data and use that data. And the third priority is probably usually the people. But, we're questioning whether those priorities are right. There's any number of examples out there of organizations that have taken technology that is class-leading technology, implemented it, and failed because the people won't trust the technology and the data. So there's a lot to be said about bringing the people along in the right way and building their trust, not only in the data, but also in the technology that we're going to use. So we need to have very clear objectives. We need to have a process. But most importantly, we need to have the people on board. And I found this piece of data from Psychology Today magazine that when you're introducing a new behavior to a group of people, it takes an average of 66 days for it to become automatic. And if you consider that you implement a new piece of technology, and if you don't see the benefit straight away, people lose interest. So having the people adopting the technology before it's implemented is absolutely key. We have to bring them along. Otherwise, the projects or the initiatives will be doomed to failure. So I'm going to hand over to Bill now, and he's going to talk a little bit more about the human-centric approach.
Thank you, Kevin. So for the next few minutes, I want to start a discussion in a more descriptive frame rather than a prescriptive frame. I think you're going to get a lot of good information this week on maybe some specific techniques and technologies. And what I thought would be helpful right now at the start is just to do more of, again, a philosophical description of what the challenges we face as we approach our needs to get more information into the hands of our users, whether that's our customers, whether it's our operations people, whether it's anyone throughout our organizations. And so one of the starting points I've found is helpful when you have to look at all the data sources that you might have is to start by understanding what you know and maybe what you need to know, what you need to find out, and really having that useful baseline structure. And when you're looking at data, again, when we talk about data quality, the starting point of that is whether or not it's trustworthy. And a lot of times we have legacy information that may be more complete but less of lower quality, or of higher quality but less complete. And so many times we're having to select between sources. And much of what we can do there is guiding our selection based on the task that we're actually trying to achieve. What are our goals? And if you know what you want to do with the data, then you have a lot better way to determine what is part of this solution or not. And Kevin kind of alluded to this. Do we want to bring in as much data as we have, everything, the whole kitchen sink, or do we want to spend some time up front making some decisions about prioritization or just what needs to be included? And a lot of that really is informed by the task at hand, the problems we're trying to solve. And many times, too, we're looking at that, finding that good cross point of accuracy and relevance to the problem at hand. And as a further consideration, when I say cost, the cost typically is not storage. The cost is either curating, validating, maintaining, and ensuring the quality of the data that you've put into your system. There's also a cost if the information is inaccurate and it isn't caught. So there's, I think, again, tailoring to the specific needs and how it's going to be used, considering the users, is really useful in terms of making those decisions. When we think about data quality, many times we realize that there's a number of different tasks, and we could start almost anywhere in there. Just pick a place. And what that really says is there's a certain amount of iteration that's going to be necessary as you're bringing things together. But I would suggest that one useful starting point is in starting with the initial quality of your data. If you can do that, then you have a better handle on just how much work it's going to take to get to the point where your system is providing you results that you can actually base actions on. Many times you have legacy systems. That could be control systems, it could be business systems. You think about SAP or Salesforce or your historians. And now you want to pull that information together. And you're going to have to decide many times, what is your primary source? What are your secondary sources? And it may be that for certain parts of what you're doing, that changes. Something could be primary one place, secondary for something else. But to the users, you want a very consistent set of information that's in front of them. And again with that, as we look at mapping that validated data, that kind of bleeds into the next item, which is fitting to our use cases. Once you've defined your problem, or as you're defining the problem, as you say, oh, I need this information in order for this to be a useful predictor of what needs to happen next. How am I going to make decisions with this information? And so all of a sudden, you can again start that process of filtering down and getting down to the part that is most useful and has the most value going back into your organization, so that you're going to find that there's certain things that you thought you needed to know that you didn't, and other things that you didn't know that are going to need to be included later on. And then as you've established a certain initial level of data quality, key to maintaining that going forward is to having proper standards and conventions. What do I mean by that? It could be how you name instruments in your plant and how you identify sites. It could be how you identify customers, or how you identify contracts, how you identify what you call something. You know, arose by any other name, but really many times you find that there's jargon even within your organization that maybe means something different to different people. And so you want to make that as common and consistent as possible. And with that is really, if there is data entry, I would say minimizing the amount of data that has to be manually entered. But when it is, try to use standards also there to control what's entered. Have as few free-form data entry fields as possible as a general guidance, because if it can be spelled or punctuated a different way, it will be. And although that may sound trivial, you find that when you start looking across multiple sites and pulling information together, that the concept of what is a unit, what is a site, how are we naming them, is all over the place. It's something that we've certainly dealt with over the years in our business, especially as sites are renamed. Sometimes they're under new ownership. I've even had sites where the equipment literally moved from one country to another. And so you can, if you're trying to track a specific piece of equipment, you're going to have the flexibility to be able to do that. Now that you have defined what you want to do, you have an idea of what data you need and what sources you're going to have, whether it's real-time data collection or whether it's coming out of existing databases or capturing data that's entered as part of your business process, you need to select your technology. And at no other time ever has it been more possible to bring in a collaborative environment where you can bring your subject matter experts together with the people who are more experienced in putting together solutions and applications. You can really also gather all the business knowledge that you have and actually allow people to work together on what is this going to look like? What data has to be shown? How does it have to be shown? What are the options that we need? What other kind of reporting do we need? And really do that in an iterative fashion. A lot of times we talk about things like Scrum or Agile development, but really in many ways it's simply having a common vision and being able to make all the stakeholders have an opportunity to weigh in and help shape this for the future. Many times you have to consider also all of your legacy systems. What legacy systems must you have connected? Are there some that need to be replaced as a part of this process? And you're going to, and at each junction, you're going to have to really evaluate those things. You know that you don't want to lose something in the process of building something new. And here's where I think we have a lot of opportunities that are missed. And that is, we'll have a new campaign, something that we're going to do, whether it has to do with maybe maintenance and asset management systems or some other kind of larger program. And many times, there are steps along the way that seem to, at least initially, and maybe going forward, adding to your workload or adding to someone's workload. And the question is, what kind of acceptance are you going to have if you're actually adding to someone's round of tasks? Now, so implicit in that is being able to identify what is the advantage that this offers to your stakeholders. And many times, too, the ease of use that we have is generally the level is much higher than it used to be. There's really very little excuse for having systems that anymore that don't have a flexible and intuitive interface. There's a lot of legacy systems where you would say, well, this system just doesn't allow that. You know, we can't add any more fields, we can't do that report, we can't support a different paper size, just silly things. But you would say, this is a wall. That should not really be a limitation anymore. And when we consider how large of an application we're building, the scalability obviously affects the cost in some cases. It also may affect the complexity. It may affect the infrastructure that you need to support it. And so determining, going in, maybe the volume of data that you're storing, the volume of data that you need to be able to query at any given time, the number of users, and all those things that might affect the size of it. And the good news is whatever technology you're looking at, almost always you have a starting point that is either low or no cost, depending on the end user license agreements, that can get you started and make sure that the technology is viable for your application. And then you can, of course, scale into the commercial versions as you go. And one of the temptations that are in pitfalls that I've seen at times, especially even with myself, is the technology is interesting. If we're here, most of us here, we're interested in the technology. And sometimes the technology, we have a sense of we can do this, and sometimes we don't stop and ask, are we adding value if we do? And so we want to make sure that the priority of the function that we're trying to achieve and the people that are going to be expected to use it are kept present in our design process as we go through. So I'll close with just a couple of comments on an internal set of tools that we've used successfully within Siemens Energy for 20 plus years now. And this started out as a web-hosted service for viewing legacy controls code. And we did this because we had hundreds of sites and we wanted to be able to quickly call up and review code, especially to support customers, to maybe look at a particular solution and see how it worked if we wanted to apply it in another context. And this allowed us to do that very quickly and easily. But one of the things that we noticed as we had that data together was this also started to help us integrate the design of the control system from a hardware standpoint. And once we could integrate the hardware system, we could start looking at the bills of materials and the ordering of parts and instructions, drawings, and assembly, and finally test of a system. And a full project life cycle where project managers could also maintain the status and updates to the projects. And all of this really has been developed by a small team working closely in what we call tightly coupled collaboration with the end users. So we're incorporating multiple disciplines over now more than 2 decades and more than 500 users worldwide. So I would say that's a very successful example of how we started off a long time ago, have seen several technology shifts over that time, and have still managed to maintain usability and relevance throughout all of that. And so what I took away from all of that was key was always not the technology, not the data, but that it was including the users, keeping the users part of it. They always had something that they needed to get done that we could help with, and that also ensured that the data would be maintained, would continue to be more and more useful and relevant over time. So keeping users front and center in all of this, in my view, is one of the most important factors of a technology program. Thank you.
Thank you to the Siemens team. If you do have any questions that you thought of during their presentation, please submit them or hold on to them post when we wrap up. So I'll turn it over to Sean now at Aviva, and he'll be up next.
Great, thank you. Excited to be here today and have the opportunity to present to you. We're going to start, excuse me. We're going to start with this presentation, and we're going to look at some of the challenges that we're faced with in the management and then transformation of all this industrial data that we have available to us today to drive business outcomes and improve profitability of our business. And then what we're going to do is take a look at this connected industrial economy. And we're going to take a look at this connected industrial economy through the lens of a large power company that has deployed this within their business to really provide a new service to their customers, both on the residential and commercial side of their business. And then the third part of this presentation is going to focus on a use case of the largest energy company in the world, on how they're democratizing their data and with the use of artificial intelligence and an information structure that fuses together all of their engineering information, operations information, along with their asset management related information. So data is the new currency of the industrial world today, and its collection and archiving and transformation are the table stakes to play the game. And there's no shortage in the amount of data that we have available to us today. In fact, there's been a study done, and it says that 50% of all the industrial data that we have available to us today was created in the last 2 years. It's pretty amazing. And it's even more amazing that it's anticipated that this will still hold true 2 years from now. And so we've got this massive amount of data that needs to be managed, it needs to be interpreted so that we can drive improved business performance, improved outcomes for the company. And an interesting part of this as well, or fact, is that in 2022 alone, it's expected that there'll be 93 zettabytes of data that's shared and copied and contextualized. And 93 zettabytes is 93 with 21 zeros. So a lot of data. And it's one thing to have all of this data and information available to us, but then it's another to translate this into some outcome for the business. And so another study's been done by Seagate, and they found that only 32% of all the data that we have available to us today is being used to drive business outcomes. And that the other 68% of data is going unleveraged. And so there's a tremendous opportunity here to really improve on how we're leveraging the data that we have available to us today. And oh, by the way, as that amount of data continues to grow over the next 2 years, the amount of data that's going under leverage is going to grow along with that, unless we take some decisive step that really allows us to build the contextualization into the data, to use state-of-the-art technologies like artificial intelligence to transform in automated ways this raw data into actionable intelligence for the business. So we still have today this disconnected environment, and systems aren't always communicating with each other. People don't always have access to the information that they need to make timely, informed, and accurate decisions. We have assets that are failing and not operating at optimal performance. There's times when customer commitments are not being met. And all of this leads to reduced profitability. And what this presents is really an incredible opportunity to improve the way that we're not just managing data, but then the way that we're transforming data into these business outcomes. So another dimension of this challenge that was mentioned earlier today is the sharing of data. And so it's been found that just in the industry, we're often not really super willing to share our data with our ecosystem of partners and suppliers and customers. And it's been proven that those that do share data outside of their own businesses with that ecosystem are getting 3x more measurable economic benefit by doing that. And so this is this connected industrial economy where we're connecting people and assets and information and data together in such a seamless and non-limiting way that we can drive optimized performance of our assets, optimize reliability of our assets, and optimize profitability of our companies. And this, really the core foundational aspects of this are open communications. It's fusing together all of the engineering information with the operations information, with the asset management information, so that decisions can be made in a timely way, and fusing this together and presented it with 3D views across the business. It's AI-based simulation and generative design. It's closing the loop on the supply chain and the value chain within the business. And so there's a credible opportunity that we have to really take this forward with existing technologies that we have to drive these improvements across our businesses. So a company that's doing precisely this, Dominion Energy, so they have a growing number of renewable assets that they're adding to their generation mix. And what they've been able to do is take all this information and data from the edge, securely share that with this industrial data hub in the cloud, and then what they're able to do is further contextualize it, further enrich that data, and then make this data so that it's available and shared with their customers, both on the residential side and commercial side of their business. And then those customers can translate that into some benefit for them on how they're using their energy consumption, or there are more efficient ways to do that. How can they lower their carbon footprint? How can they improve their sustainability? And the way Dominion was able to do this is they put in this data infrastructure, this PI system that collects all the data from the renewable assets at the edge. And it archives all of this information second by second, minute by minute, allows you to extract it in that granular level of resolution or extract it in aggregates. And then the next layer of this is this really important layer where the data gets organized and contextualized. So this asset framework. And then that next layer is all about analytics. So these are self-service analytics where the users of the software can go in and easily build analytics that are driving some performance improvement or some reliability improvement or some improvement within the business. And oh, by the way, those analytics are built and attached to that data model. So I can build an analytic today. I might find a better way or an improvement that I can make to the analytic tomorrow that's associated with a specific class of assets. And I don't have to go back and rebuild that analytic 100 or 1,000 or 10,000 times. I can do it once at this model template layer, and it will ensure that all of the assets are updated accordingly. And then the next layer is this event frame layer where they can go in and they can build all of these events that are of interest to their business. And again, self-service, anyone can do it. They can build their own events that are just for them or events that can benefit multiple parties across the business. So they go in and build these event frames, and those event frames then can trigger email or text notifications or they can be linked to their enterprise asset management system where work orders are automatically generated. So automating and closing the loop of some of these processes within the business. And then at that top layer is this rich visualization layer. And the rich visualization layer, like the event layer, like the analytics layer, is linked to that data model and that data model infrastructure. So I can build these displays, I can roll them out across a fleet of assets very effectively, efficiently. I can maintain over time those displays that I've created and those views of this information. And the key with this is it's putting the information in the context of the consumer of the information, their role within the business, and how they want and need to be able to visualize this information to make better decisions. The second piece of this is this connected industrial economy where this data is being securely shared to this data hub in the cloud, where this data is further enriched, it's further contextualized, and is securely made available, in Dominion's case, to their residential and other customers that they're serving, so that they can make better decisions about their energy consumption, about their carbon footprint, about their sustainability. And the great thing is once you get into this sharing mode, they can easily share through this same infrastructure this data with their ecosystem of suppliers and OEMs and other entities that they're working with and doing business that maybe can take this data and further transform it and feed this back to Dominion to bring a new value proposition to their business. And this is an example or case study of Saudi Aramco, largest energy company in the world, and how they're democratizing data. And this was a really key piece. They've had this PI system in place, collected 8 million tags for a long period of time, but they really found that they needed to get better at how they were contextualizing and using data in the business to drive decision making, to advance in that area. And they did this as part of their 4IR, Fourth Industrial Revolution, digital transformation strategy for their business. And this was a key pillar and key foundation of that strategy. And what they did is they put in this unified operations center so they could visualize all the information from all their sites. They can look at it at the regional level, they can look at it at the plant level, they can look at it at the unit level, all the way down to the asset level. So being able to drill into this information through the state-of-the-art visualization capabilities that they have from this centralized command and control center. And then what they did is they underpinned this with this information digital twin that connects all of this design information with the operations information with the asset information. It fuses this together, it organizes it through a data model so that all this information can be readily accessed by anyone across the business with the goal of being able to access any piece of information about the asset in 3 minutes or less. And the next piece of what they've done is they've started to now implement these value pillars of this information digital twin, and they chose to start with predictive analytics and predictive maintenance. So leveraging artificial intelligence and machine learning to automatically detect efficiency problems, reliability problems of their assets days, weeks, months before failure occurs. But not just starting and stopping with indication of this condition, but taking it further with fault diagnostics and prescriptive actions of what action should I take based on this current condition that I'm faced with, to remaining useful life, and really closing that loop, if you will, to be able to come back and see all the information that I need to be able to see about this asset, its design, its operations, its asset management information, to be able to make fast, timely, and accurate and informed decisions on the best way to maintain this asset and the best remediated action I should take to repair the asset. And if we just take one more layer down of what this looks like, this is what it looks like. And it's putting all the information about the asset in context of the physical asset itself and its connectivity within the plant. So I now have this connectivity model that allows me to see, do I have any other early warning alerts with some of the assets in this part of the plant? Because I can start to better remotely plan my work. Because if I'm going to be in this part of the plant, maybe I should take a look at this other problem that I have as well. It's a great tool for troubleshooting operational issues, design issues, asset management related issues, because all this information is fused together and available to me in the context of that physical asset. So we've got it's really an awesome thing and opportunity when we can treat data as an asset to the business. But the data alone, as the currency of the industrial economy, has a fairly low value until we start to translate that into some improvement in the business. The really great thing here is that we can improve the performance of our assets, we can improve the reliability of our assets, and we can reduce our carbon footprint, and at the same time, our planet profits as well. I do want to invite you, we do have an exhibit out here. We have a lot of this technology that I talked about today on display in the exhibit area out here. And we're going to build from this presentation to the next. We've got a session tomorrow that's called The Many Faces of the Digital Twin. And we'll be building off the presentation. We'd like to invite you to participate in that session as well if you're interested. Thank you very much.
We'll go to them. Thank you, Sean. So our final speaker of today is Jonas, and Jonas is with, I apologize, Aperio Systems and the International Paper Team.
Great. Okay. Let's see. All right. Thanks, everybody. My name is Jonas. I'm with a company called Aperio, and we are a product company that work with our customers to solve data quality problems. And today I'm going to give you a few minutes of my thoughts on this topic, how data quality is important to address up front and proactively, and the impact of poor industrial data if you don't, and what we think one should do about this. And then I'm going to pass over to our friends at International Paper here, who is addressing this in a proactive way, and so that you can hear about what they're doing on this topic. We worked with Gartner to ask 160 operational leaders what they think the cost of poor data quality is to their bottom line. In this case, it's revenue. And their answer was 5 to 6%. Studies show that it's way worse than that. In fact, studies show that the cost is probably more in the neighborhood of 15 to 20%. Poor data makes bad business decisions, right? So it's interesting. Most people seem to underestimate the true impact of poor data quality to their industrial operations. So how does this affect, how does poor data quality affect your operations? We asked that question too, and not surprisingly, it's the usual suspects. Bad data gives the operator the wrong information, so they'll make bad decisions, or bad data causes unscheduled downtime or unplanned outages. But also poor analytics, of course. I mean, obviously, if we base our analytics on bad data, we have to expect the wrong outcome, so no surprises there. Some other interesting areas, for example, greenhouse gas emissions reporting. We talked to a lot of people that either underreport and they find out that later and they pay fines, or to be on the safe side, they'll over-report and they pay extra fees for that. So overall, basically, poor data makes for poor decisions. So data quality is a serious problem. We know that. We asked people to grade what they thought was the state of their data. About half of them didn't think their data is good, but they couldn't really tell why. So that's interesting because maybe it isn't, and maybe we need to measure that, and that's what we are advocating for here, is that, before we do anything with the data, the first thing we should do is at least get a handle on, what is the quality of it, right? If we're assuming that maybe a big part of the data that we have in our Pi server or whatever other historian or cloud database there may be, is unreliable, maybe start by measuring that and get a handle on that and get metrics and then track that over time, so that we know. About half the respondents said that they clean the data, their data analysts clean the data post-production, and actually we hear this a lot. Companies spend maybe 50 to 75% of their data science or data analytics budgets cleaning data instead of doing anything useful with that data. So yeah, a lot of effort goes into fixing data problems. A lot of budget, a lot of money goes into that. But overall, we hear from customers that it is a difficult problem. Most people don't have a good handle on how to solve this in a scalable, repeatable way. It becomes a very reactive and tactical, type of exercise. So what's happening today is that customers or companies, they put manual procedures in place. They address data quality problems reactively once they find out that they have a problem. The greenhouse gas emissions report is not reliable. What should I do? Go and fix it. Or build in basic data quality checks into your business analytics tools. So that could be in your analytics screen. We start building in scripts and set points and things like that. But the problem with that is now it becomes a very, very tactical and not so much of a scalable approach to this problem. And so ultimately, that might not be the best idea. So instead, look at data quality as a proactive, holistic issue that should be solved upfront, that should be solved at the data database layer, the data historian layer, so that any user of the data knows that there's going to be clean, reliable data to base your decisions off of, or that we know that what the quality of the data is, rather than addressing these problems tactically and case by case. And here is our friends at International Paper who's done that and who's looking at this problem of data quality in a strategic and proactive way. So we're going to hear from Rick what you're doing about that.
All right, thanks, Jonas. So my name is Rick Smith with International Paper, and I'm sitting over here chuckling because some companies have come to me and said, you discovered this data problem 10 years ago, and you've been talking about it for 10 years. I said, well, no, actually it's been 35 years of the 39 years I've been with the company. So the good news is we're starting to see some traction. But what's the challenge behind it? Why is it so hard? Well, there's really been no way to, other than what Jonas just said, it was manual processes. People would get a report, they said the number's wrong on the report, go figure it out why. Well, why is it a challenge? International Paper split off part of our company last year, but we still have 29 facilities around the world with 1.5 million Pi tags. If you're checking these one at a time, or even by class of tags, that's a lot of information. And in the past, no one was really looking at it. Jonas mentioned the cost and the things that people are having to do to manually handle this. And we've been doing many of those techniques ourselves because we couldn't handle it as a systemic problem. Some keys started changing a couple of years ago as we started looking at this effort called the middle of the future, digital twins, machine learning, predictive analytics, all these tools that relied on data. All of a sudden, it became aware to leadership that the quality of data was important, and they said, maybe we should have been listening to Rick 10 years ago when he was trying to tell us there was a problem. I said, I don't care about the past. Let's go fix it now. Part of the thing that really is when you don't put quality checks or integrity checks into the systems at the lowest level, by the time you get 2 or 3 steps away from that data, you can't tell if it's good or bad. So what kind of data do we have? So this is just typical of a paper industry. It applies to all industries. We have process data that historically was in that some minute in the old days when I started up that you'd get a piece of information. Well, now it's sub-second. Our slow data is now coming in every 2 or 3 seconds. So the amounts of data is enormous. That's the process data. We also have manual tests that come in and stored in a different data silo. On the paper machine, I'm sure many people haven't, they see Xerox paper, they don't really think about it. The machine can be 400 or 500 inches wide, traveling at 60 miles an hour. And we have scanners that go across the sheet taking images, not images, but samples of that equipment as it goes across. 1,000 samples every 15 or 20 seconds. That's a lot of data. And yet we're still only getting a part of it. We have all the maintenance records that we want to join in, like Siemens was talking about earlier, of it's another silo that you have to add these assets to. So you have all these silos, all these data owners, and no one's really talking to each other. The question, and I refreshed these slides last night. I was looking at these slides again last night because I'd forgotten about this, but we hear about bad data. Everyone says there's some bad data out there. Well, what does that mean? And an executive asked me that last week and on an open call, and I said, there's 500 statuses that come back from the various systems about what is bad, and every one of them has a different meaning. But I like what I put here. Data is bad if it's not what the user expected. That calls it down. Then we get into the tools of how do we do it and track it down to any of these 100 or 500 causes of why your data is bad. The other thing they heard a lot about is what is stale data. Now, stale data is any data that's not refreshing when you expect it to be. So if I'm not getting data for a couple of minutes from something I should be getting data every 5 seconds or 10 seconds, we could call that stale. As we started looking at it, some of this data that should have been refreshing very frequently hadn't refreshed for days, and no one had noticed, and no one had therefore done anything about it. So by the numbers, how big is this problem? We got 29 facilities, 46 Pi servers, 1.5 million tags. One of the projects that once we started looking at middle of the future, trying to analyze how big is the problem, we started putting in systems and statistics to monitor it, okay? So we have 1.5 million tags, 45,000 of them are bad, one of those bad statuses. That's 3%. That's good because that number used to be 8% 2 years ago. Once we measured and identified that we want to attack this as a problem, we started putting in the remediation and tracking to fix it, and then be proactive, not only looking at fixing the causes that we were finding, but saying how does that cause go back to symptoms in our processes that we can fix to keep them from getting bad. And then we have just under 20,000 stale tags. And I described some, if a sensor goes out or whatever, the data goes flatline or we don't see any data anymore, we call it stale. But it could be things that we did to ourselves. From a sustainability standpoint, we put some places in our equations where we put constants or things that didn't change but once a year or every 5 years into actual formulas and made them available as tags so we could look at them, number one. When we changed them, they got historized so we knew. But now that we're monitoring for the stale tags, those start showing up as stale. So we wanted to go back and start changing our processes. So that number was also much bigger 2 years ago when we started, has now come down very much. So steps to addressing these bad tags, I've kind of alluded to some of it already. First, you got to measure the scope of the problem. How big is it? You got to classify into the various things that it could be, because there's many reasons that data can be bad. You need to break it up into those reasons and attack it by class of the type of problem. For each of those classes, we have to identify what is the resolution for each type. It may be within the scope of something I can do on, or it may be in that manufacturing village of IT people, OT people, process control people, subject matter experts that have to be involved in the identification, but also in the resolution, because they all have steps into their ownership. Because the problem is so big, we have to prioritize what we're going to be looking at. We heard earlier that maybe we don't need all of that information. Information does have, some things are more important than others. We definitely want to fix the things that are the most important first. And then we have to periodically look. Now, when I made this slide, we are currently running with every month, we review the statistics and actually look across the entire enterprise to check in. Hey, IT person, hey, process control person, are you keeping your numbers down and are they trending in the right direction or do we have a problem? Recently, we made a commitment we're going to start doing this report every day and people are going to start getting notified by exception as opposed to just waiting for that report to call. That shows an improvement in our understanding and commitment. 2 years ago, we were doing nothing. Today, we're doing monthly. Very soon, we're going to be doing daily. And part of it is because we've been able to reduce the numbers enough that we can actually handle a daily or weekly analysis as opposed to once a month. And believe me, people didn't want to be on those once-a-month phone calls because they're going to be called out on not getting stuff fixed. So what's the impact? You heard it before. If the data's bad, you can't trust it. I heard a salesman say once, I think the United Airlines commercial from back when I was much younger, they'd lost a customer, and the president was handing out all these tickets to go visit your customers. Same thing applies for data. When people lose comfort in the data or the systems, it takes a long time and a lot of money to get it back. So you don't want to lose that work. The other thing that happened is part of this middle of the future work that relied so heavily on data, we were able to do some analysis. And part of that analysis was, in our systems, we can choose how much of that 2-second data how much does it have to change before we store it? If you make those limits too broad, you might miss information. If you make those limits too small, you store so much information it takes a long time to retrieve. But we had a perfect case where we had some before and after that said for this big project that we were proposing that was going to try to save lots of money, we would have missed 8% of the opportunities the system would have told us just because we didn't have those settings set right. For the first time ever, I actually had real dollars that I could put toward a data improvement project. And with the success of those projects, we started seeing more and more emphasis on this. And it's all driven by those model building, predictive, machine learning projects, because bad data means it's going to take the systems longer to converge and get to a solution if they can make a recommendation at all. And if the data is bad enough, it will never converge. So you can't learn anything from this information. One of the points is all of the systems flow data forward in one direction. You can follow, hey, this is the source, it's sending it to here, to B, to C, to D. None of these systems are built to track the problem backwards. So one of the things we did several years ago was start building some of those systems that our end users could track this data path backwards. Because what they started with was the number on the report is wrong. How do you go backwards? And then finally, the scaling of the process. I mean, the recommendations are automate as much as you can, start small, chip away at it, Celebrate the successes, and that includes letting upper management know that you are making progress. Keep going, go to the top, start again. Thank you.
Thank you, Jonas and Rick. So, this is the audience participation portion of the, of the session. So, for starters, we're already experiencing a data connectivity problem because I told you, post your questions in the app. Now, I'm not sure how to access them, acquire them, and I don't have the app functioning right now. So I'm going to look for some of the coordination team here to see, one, if we can get some access to the questions that we have. Sure, if you can read them to me, that'd be great, and I'll share them for the team here.
All right, so one of them is, how do you decide where to start with such a large volume of data?
So the question was, how do you know where to start with such a large volume of data? Does anybody on the panel want to tackle that?
Well, I kind of mentioned that in my talk, in that, you know, start with the reports that people are looking at, and things that affect the bottom line dollars, or looking where you're having failures. Track what data that is, and that's a good place to start, and it gets you high visibility when you get successes.
Great. Anybody else want to add anything to that?
I guess it depends a little bit on the context of the question as well. From a data quality perspective, where do you start? That's a huge question, depending on the type of data that you've got and the type of data that you're looking to collect. But you know, we've always taken the approach that one of the key steps to start the process is to limit the access for people. So the less people that have access to change data, then slightly more control you have on that going forward. And then as you start to improve the quality of the data, you can reinstate access rights and give more people access to it. But as Bill said in his talk, you need to have the process and the procedure in place as well. Because as new data comes into the system, you don't want to corrupt the quality that you've already achieved. So you need to have process and procedure that dictates the format and the type of data that you're going to pull into the system going forward. But you know, for me, access is always a huge issue. Too many people have access to data to corrupt it. And if you want to start on the journey towards good quality data, you need to look at who's accessing it to start with, work on the quality based on some of the things that Rick said in his talk, and get to a point where you're confident that the quality is such that when you use that data, you're going to get good, actionable decisions.
And go ahead.
I was going to say real quick to Rick's point, I mean, I think you had a bullet there that basically said measure. And I think that's, you know, you start by measuring top down, right? Because, I mean, we spend millions of dollars every year on OSI soft PI servers, keeping millions of tags in there, and we don't even know, you know, we don't know the state of that data. So until we start measuring that and then do this sort of like rinse and repeat, you said monthly goes to weekly goes to daily, so you can see the progression. That would be my answer, because otherwise it just becomes, you know, kind of like a never-ending whack-a-mole.
Yeah, and you know, I would just add to that I think even a lot of times we jump right into the data. I think we need to take one step back often and focus on what are the business outcomes that we want to achieve, whether that's improved data quality, improved reliability of our assets, improved performance of our assets. Because I still see a lot in the industry where companies are deploying data lakes in the cloud, and they're just pushing all the data up to the cloud, not necessarily really understanding how they're going to use that data to improve the performance of the business.
That's true.
Can I borrow it for this? Thank you.
Yeah, I was just going to add that, you know, I think Rick is right in that the problem's always there, but it hasn't had the value to do something about it. So I think it almost takes a use case to alert the management or operations high enough to get the interest. So For example, you could say we stumbled upon it. We knew the issue was there. We want to work on high-level AI, predictive analytics, but if the foundation's wrong, it's going to show up here. So you do your proof of concept, and you find out there's an issue, and it will drive you to the foundation, one way or another. If it's not a person saying, I don't know why you're doing AI, we know all this data is not trustworthy, it's going to be a person, or it's going to be a result that you're going to want to try these really cool things, but if you're not doing the fundamentals, it's going to show up pretty easy. So I think it's not so easy to say, I want to go do it and look at 1.5 million of tags. It's going to be looking at the business case as what things do we want to try, and that's going to lead you there.
Yep. Yeah, and I'll just dovetail onto all of that. I think Sean sort of hit what I was going to get at. I mean, without understanding what your business outcome, what is your use case, what are you trying to do? I know the question was probably rooted in the quality and just the volume of data, and I think it was Shakespeare that said, data, data everywhere, but not a drop to make a good business decision. So I'm going to copyright that. I just said that. So focus on that. So next question. Okay, to International Paper. What tools or processes did you add to track data backwards between the different data inputs?
Well, I wrote it, so essentially, for anybody who's an IT person, if you think of a graphical model, and these are just tools of connect A to B, connect C to B, and then run that in reverse. So you have to essentially dump out information, configuration information from each tool, because they don't talk to each other. But you're adding keys such that you can join them either in a SQL database or in a graph model. I did the traveling salesman problem and all that stuff in college, and I didn't get to use it for like 35 years. I finally had a problem where I could use what I learned in school. That's where, and I'm sure there's tools out there to do it now. There was nothing 8 years ago, so I wrote something. And it's still going on today, so I keep looking for someone to just say, we've got that for you.
Good, thank you. Okay, next question, and this looks like it's to the group. What are some tangible things I can do to proactively clean my company's data? The $1 million question.
Turn off an important report, and then let people ask why.
Anybody else want to provide some input there?
I don't know if it's proactive, but I would say if you do something, it should be as close to the source as possible. So I think you might find that a lot of tools will clean the data, but if the source of the data is here, and you've got an application up here that's going to clean it, but now you're putting another application here, do you connect it to this one? So, I mean, it's always better to do it as close to the source as possible.
So
otherwise,
minimize data hops or things like that.
Otherwise, you just repeat the same cleaning. So,
I would also add that you need to know the objective of what you're trying to do with the data, because that might determine how you are going to clean it. And so the steps to doing that might be more or less complicated based on what you're trying to do with it, because people just look at their data and say, well, let's just clean it, but what are we going to do with it in the end? Being an industrial statistician, I always say you got to know what you're trying to do with your data before you collect it and go analyze it. So I think that applies to cleaning the data as well.
And what does clean mean?
Filtering it, or
so
yeah,
what does it mean?
You have to define clean, right? Yeah, exactly.
I guess building on that as well, I think the objectives are absolutely key. You've got to have a vision for what you're aiming for, and then work back from that and go and talk to people. A lot of people will tell you where they think the problems are, so you can use them to help guide you. But you've got to go look for yourself as well. Understand why people don't trust the data that's in the system. Understand how it got in there in the first place, and put a process in place to make sure it doesn't happen again in the future.
Somebody asked me a couple of years ago a similar question, and Tim was in the room, and he's a statistician, so what he thinks of is different. And the person asked about outlier detection. I said, back up. We're just trying to get to flows are not negative, flows are not full scale when the pump's not running. Yeah, we may do outlier detection later, but some of this, you got to start simple. And like you're saying, in that example, you can start very close to the source of the data. Fix it right there, and then it flows out. Once you do that, you can start doing, well, what is outlier detection? How does my cleaning of the data affect the statistics, which is what I was thinking about for Tim. Because you can actually change your process statistics depending on your method. As an old Chemie, I don't really care, but Tim does as a statistician.
That's why I sit between them.
Great, thank you, everybody. Next question. You've mentioned about bad data. Could you share how to struggle with this, maybe how you struggled with this challenge to conquer the people's trust? And that's probably an end user question. And I'd pose some of these to everyone in attendance as well, because everyone probably has personal experience with these questions. So this is a team sport. There will be participation trophies given at the end. So feel free to raise your hand. We'll find a way to get your input up here. Anybody have any thoughts?
Well, I think you've got to have stakeholders in the business, so it's not just you as being responsible for data quality, but all of us together are working, and this is everyone's role within the business is to help improve the quality of the data, to give that feedback when they're looking at reports or they're looking at the contextualization of the data and it's not what they're expecting to see. You need to have a formal way of feeding that back into the business to make those improvements.
And I'd say struggling with people's trust. I think it gets back to the use case example, because if you come back and say, here's our business problem, and you can quickly tackle insights into that problem in a quick, effective way that they buy into, that's how you can quickly build trust to then let that and continue to build momentum.
I think the other aspect of trust, and I'm sort of speaking more from a maintenance perspective, when you're talking about using things like AI and machine learning, there's a reluctance for people that have been in the business for a long time to trust what that's going to do. And they fight it, and they most definitely will do everything that they can not to believe what that data is telling them, because every 3 months for the last 30 years they've gone and done a check on a pump. That's their behavior, and that's what they're used to doing. But then when you say to the same person, you know, when you're going home tonight and your low fuel alarm on your truck comes up, what are you going to do? And they're going to go and fill it up with gas because they believe that that's telling them correct information. But then how often do they actually calibrate the low fuel sensor on their truck? Never, probably, in the lifetime that they have the truck. So by throwing out some real life examples, you can start to change how people think. But the biggest challenge with the trust is getting over people's habits and bad behaviors that they've spent the last 30 years cultivating. So you've got to try and engage them in the right way. And if you can find somebody from you know, who's got a lot of experience and a lot of influence, who you can convince, they will then help convince other people that trusting this data might actually be quite a good idea.
I would say one more thing, that it's all the old saying, seeing is believing. You can't tell them what's going to happen. They have to experience it. They have experience in their process of what they expect to see. And then you go in and you help them clean up their data and make it better, and then they see for themselves, oh, that got what I thought it did. And then 2 or 3 more times it does that, it eventually becomes, okay, well, I trust that because I've seen it work 3 or 4 times and it's getting what I expect. So I think it's getting that user involved and having them to experience it, not just telling them.
Yeah. I was going to ask that relative to international paper, because too often I think we eliminate the person that can extract the most value out of that data, out of the equation, in delivering whatever it might be of doing the analysis and technology. And trust is built by that person being an intimate part of the team to make those decisions. And I guess I'll add a question to dovetail to that. I mean, and maybe it's good for the international paper team. I mean, everything when you look at data, there's a people element, a process element, and a technology element. What do you think's the biggest piece? We talked about some of the people, and we're talking about trust of like that comes into this whole equation. And what's the I'm trying to think of the right word, the biggest contributor that we think can have the biggest impact in a short term?
The people.
People.
And the hardest to change is the people, the hardest to convince is the people, because like that statistic said, I mean, you got to do something for 66 days till it becomes habit. And then as soon, and for a while there after that, you have this period where if I don't get what I expect, I'm going to go back to my old ways. So when a problem came up a few years ago, I said, I have to go attack this and I have to do it quickly. I can't wait because I've already gotten up here. I can't let it drop down again. Mm-hmm. And so we took on some work to try to fix that problem, identify the root, and get to the root cause, and then advertise broadly what it was and what we found. And you got to be honest about what you found. Mm-hmm. You know, there's no place for sweeping stuff under the rug. You got to call them like they are, and then try to address whatever processes were broken after the fact.
Good.
Yeah, I would say it is not the technology. I'm convinced the technology will work. But we're our own worst enemy as the customer, because companies been in business for 50 years. Most companies in pulp and paper are very mature. And so we have well-established processes. And I'm a true believer that well-established processes are the enemy of innovation. And so when it's that way, it's hard to think of a new way. We have these people here because the data is bad, but is there a better way? It's the desire of the company or the industry to want to do analytics that will drive the cleaning of the data. It won't be the reverse. It's very hard. In fact, 30 years would say you're not able to convince from data quality issues up to fix it. It has to be a problem down, I think, is how you get it done.
I'll go to the next question. Oh man, you guys were good with questions. Any reason, so this is a steam boiler specific question, so maybe. Okay, I was going to say that's going to stump this group.
Bring it on. We got it.
Yeah.
I was in sales, I'd make it up.
But that question, you're happy to talk to me later about that. So. No, we can help. Okay, so this one says, how to identify the source of stale tags, calibration of instruments, communication, process, configuration of PyTex, et cetera, and do the proper directions to solve. Not sure if anyone has anything on that, or should I move to another question?
Could you say it again?
Yeah, it just says, how to identify the source of stale tags, calibration of instruments, communication, process, configuration of PyTex, et cetera, to do the proper directions to solve. So basically, how to identify the source of stale tags to do the proper directions to solve.
You have to have, and for us, it's, you know, the IT department and process control and some of the subject matter experts, it's a shared ownership. So unfortunately, you got to get all the people in the room together to problem solve. It can fall into a class. If you have this equipment class, this is the kinds of things that we see, and we can go look there, kind of short circuit that process. But there's no silver bullet. There's nothing. It takes sitting down with the problem. I say it's hard to solve problems if you're not in a room together with a whiteboard. So you can actually talk through it. Once you've done that a few times for your business or your industry, you can then do it remotely or agnostically, or you've gotten some tools you've figured out for yourselves or purchased. But at the beginning, you got to do it the hard way.
Yeah, and I think it's, totally agree with that. And I think the interesting thing is, as you start to contextualize the data and you start to apply things like artificial intelligence to the data, you start to pick up a lot of these things. When you put in predictive analytics, one of the first things you see is improperly calibrated sensors, and sensor issues, sensors that have failed. But there's got to be a better way to do this a little bit more on the front end so that we're not always on the back end as we're deploying these solutions and applying context to the data that we start to pick up these problems. But that is the area where you often pick up those issues, and then you need to feed it back and discover what the root issue of that problem is.
And I think the key is to keep it simple. Maybe the good thing is just to have a flag that says there's a problem. It doesn't define exactly what it is. Then you can measure how many problems you have. Then you can start categorizing which ones of the problems are common and decide to go after that versus trying to say, okay, if I'm going to build something, how do I classify? That might be a separate POC. I don't know. I'm a big believer of keeping it simple if you can and clarify from there.
Good.
I think there's something else to remember as well, that we're all sitting up here talking about data quality. If it was easy to fix, everybody would be doing it. We're all here to try
Hottest
and...
major, data quality engineer. Tell your kids to study that.
And so you've got to have the support of the organization. You've got to have lots of people involved. You've got to have a plan. You've got to have a vision for what you're trying to achieve. But, you know, I've been around the industry in general for the last 25 years. And from what I can see in a number of industries, data quality is still as big an issue now as it was 25 years ago. And as we become more reliant on the data to make decisions for us with AI and machine learning, then potentially we're heading for a big fall unless we get the data quality right now. It's not something that we should be sitting back and saying, we'll do that in 10 years' time. It needs to be done now.
We're going to be making 50% more data quality issues in the 2 years.
That's right. It's true. It's true. The problem's growing as we discuss it here.
Yeah.
This may be the last question. So this is for the International Paper team. How do you track, and this ties back in, how do you track bad quality types, reasons in Pi? Does this use a separate tag?
Yes. So in Pi, so we're doing some monitoring. I'm doing some work for Alan because we always want to keep the raw information. I want the data as it came in from the field, no matter what I do to it. And if one of those things, I may want to do some filtering or some clamping, and that's the number that people are going to use. But if I've done something extraordinary, I have a flag that says what was the quality of that, and normally it says okay or normal or whatever it says. Or I might say I filtered it, or I clamped it, or something to give us something to feed out to us, some package that we could do some reporting later. So I had the raw data, I had the filtered data, so that's what we use, that's the best we got at that point, and I got the flag that says, should I trust this or not, is kind of what we have right now. And it's not systemic, it's on a case-by-case, value-added case use.
Good. Well, looking at our timer, we're at the 2-minute warning. So this is perfect timing. I think we got the right amount of questions and feedback from everyone. So I appreciate everyone speaking and presenting today. I thank everyone for attending and joining us and asking some great questions. So thank you very much.
Thank you.